Hey Jenny, ready for another tech deep dive? This one's going to be electrifying, literally.
Hey Mark, you know I'm always up for it. And electrifying? Okay, you've piqued my interest. What's sparking today?
We're talking contactless motors. Imagine an electric motor but with a twist. No brushes, no slip rings, none of that usual physical contact stuff that, wears down over time.
Whoa, hold on. No physical contact? So how does it even function? My brain is already doing somersaults.
It's all about the magic of magnetic fields. Well, not magic. Clever engineering. We're focusing on MAHLE, a German automotive supplier. They've created this magnet-free contactless transmitter motor, MCT for short. The core idea is transferring power to the rotor without times any physical connection.
So it's wireless power transfer then? Like how I charge my phone, but scaled up considerably, I'm guessing?
Precisely. It's called inductive power transmission. Think of it like a rotating transformer. One coil stays put, the other's on the spinning rotor. A changing magnetic field in the first coil creates a current in the second, and boom, you've got power for the electromagnets in the rotor.
Electromagnets. Wait, so they're not times using those permanent magnets you usually find in electric motors? The ones that require all those rare earth elements?
You got it. That's another major advantage. This is an externally excited synchronous motor, or EESM. Instead of permanent magnets with neodymium and dysprosium, it uses electromagnets. So, rare earths? Not needed.
That's a big deal, right? Because there are all those concerns about, the environmental impact and ethical questions around mining rare earth elements.
Exactly. Mining those materials can be environmentally damaging, and the supply chain is, let's just say, complex. This design avoids all of that.
Okay, so it's a win for the planet and dodges those supply chain headaches. But does it actually perform as well? Is it as good as a traditional electric motor?
That's where it gets really impressive. MHLE claims efficiency levels times 95% across a wide operating range. That's comparable to top-tier electric motors, even those in Formula E racing cars.
Seriously? So it's not just eco-friendly, it's also a high-performance contender. But what about heat? I mean, things must get pretty warm inside a motor, especially without physical contact for heat dissipation.
They've got a clever solution. It uses an oil cooling system, a hybrid actually. Oil circulates, taking away heat. And here's a neat trick. They can even use that waste heat to warm up the battery in cold weather.
So efficient, and times it contributes to the vehicle's overall thermal management? That's pretty smart. What range of vehicles are we looking at? Just small cars, or?
It's scalable. That's another advantage. They've designed it to fit everything from tiny subcompacts to huge commercial trucks. They even have a version called the Superior Continuous Torque SCT motor, built specifically for heavy-duty use.
So we might see these motors in delivery vans, buses, even long-haul trucks? That could significantly reduce emissions.
Potentially, yes. MAHLE is aiming for a substantial reduction in CO2 emissions compared to conventional EV powertrains, and they're partnering with Valeo, another major automotive supplier, to develop it further, especially for high-end vehicles.
This sounds like it's beyond just a concept then. It's actually being developed and tested for real-world applications.
Right. And because it's contactless, there's almost no wear and tear on the power transfer parts. That means way less maintenance, which is a huge plus for commercial vehicles that need to stay on the road.
Longer lifespan, less maintenance, and times better for the environment. It almost sounds too perfect. Are there any catches? Any downsides we should know about?
Well, with any new technology, there are hurdles. Achieving that high efficiency in inductive power transfer, especially at high power, is a complex engineering challenge. And, scaling up production to meet potential demand could also be a bottleneck.
That makes sense. And I guess there's also the question of cost. Will this technology be significantly more expensive to implement, at least initially?
That's a valid point. The initial investment might be higher, which could slow down adoption. But, the long-term benefits, reduced maintenance, longer lifespan, could offset that.
And what about material dependence? Sure, it avoids rare earth elements, but are there other materials in the electromagnets that might pose supply chain issues?
That's something to consider. While it sidesteps the rare earth problem, the electromagnets will still require specific materials. We'd need to look into the sourcing of those components to get the full picture.
It's a fascinating technology, though. a real step forward for electric motors. It seems like it addresses many of the sustainability concerns while still delivering excellent performance.
I agree. It's a prime example of how addressing environmental challenges can spur some truly innovative engineering.
It'll be very interesting to see how quickly this technology gets adopted. What do you think, Mark? Are we going to see contactless motors everywhere in, say, 5 years?
5 years might be a bit optimistic, but I think we'll definitely see them gaining traction. Maybe in high-end vehicles and commercial fleets first, where the benefits of reduced maintenance and increased efficiency are most compelling. What about you, Jenny? Any thoughts on adoption?
I think you're probably right. The commercial sector seems like a natural fit. And, if the technology proves itself and costs come down, wider adoption will follow. It's just a question of time and overcoming those engineering and production challenges you mentioned.
Exactly. It's a technology to keep a close eye on. And it's a good reminder that innovation often comes from unexpected places, like rethinking something as fundamental as an electric motor.
Thanks for the insight, Mark. Always illuminating.
My pleasure, Jenny. Until our next tech adventure.